In the second video, we're going to take a look at solving some rational equations that are a little bit more complex than the first one. Just as a reminder, we just finished up these three questions. Each of them are a single fraction set equal to another single fraction. On the second page of the worksheet, numbers 4, 5, and 6, we now have in this first one a single fraction and equal to another, but then we start throwing in another fraction. So maybe we have like two fractions being added and then set that equal to another. And we're going to look at using the two techniques that we just learned in the previous video, where we could either use cross multiplication as method number one, not necessarily always the best method, but just the first method we learned. And also the second method being make common denominators and then get rid of them through multiplication. So I want to show you number 4 using both methods, because you will see one of them is definitely easier than the next, okay? I'm going to do cross multiplication first, and let's see what happens. When I multiply across this way, I'm going to get 5x minus 25. And if I were to multiply across this way, it is the denominator times 1, so it's really just itself, and I get this. And now when I do that, I have to solve a quadratic. So move the 5x, move the 25, and I get 0 equals x squared. Subtracting 5x gives me negative 3x. Adding 25 gives me negative 10. To solve this, we have to factor. And we're going to get x minus 5, x plus 2. But then we have to find the zeros of the factors, which is x equals 5 and x equals negative 2. Those are the two solutions that we got. But here's what you need to look out for. Whenever you solve rational equations, when you have variables in the denominator, you have to look out for what I was referring to at the end of the last video, that extraneous solution. And that extraneous solution is a solution that arises through the solving process where you have done everything correct, but it just happens to be that if you were to plug it back in, if you were to substitute that number back in, it makes you divide by 0. It gives you an error. It's an x value that doesn't actually work for the function. And look what we have here for x equals 5. When x is 5, look at your denominator here. Think about plugging 5 in. So if I were to take x equals 5 and I were to plug it in right there, I get 5 minus 5. Well, that's 0. So what that says now, it really says 1 divided by 0, which we know does not exist. So we're going to cross that off and we're going to call this solution right here extraneous. Now, negative 2 is not an extraneous solution. If I plug negative 2 in right here, it doesn't make it 0. And if I plug in negative 2 right here, it also doesn't make it 0. So solving by cross multiplication was great for this one. We got our answers, but you do have to look out for extraneous solutions. Here's our second method for solving. This one was to create common denominators and then go from there. Look at what ends up happening. To create common denominators, you have to factor, right? So let's do that. X plus, what do we have here? It's a 7 and a 5. X plus 7, x minus 5, okay? So they both share an x minus 5. Leave that alone. Don't mess with that yet. But we do have to adjust this and put an x plus 7 here. Whatever it doesn't have, you just put an x to it, and that needed an x plus 7 as well. So to go to the next step, well, I've created the common denominator. Now look what we can do. We can multiply to get rid of it. And I just need to move this camera for a second down here. We need to multiply the equation by the denominator, x minus 5, x plus 7. When you do that here, it cancels. Do the same thing here. Multiply the other side by x plus 7, x minus 5. When you do that, it cancels. Remember, we're solving, so our goal is to get rid of fractions. If this were an addition problem and you created common denominators, please do not get rid of fractions, okay? When you're adding two fractions, your answer should be a fraction. We're solving an equation, so our goal is to use some techniques that we know about balancing equations to solve for it and get a solution. So now that's gone, and this is 1 times x plus 7, which is just x plus 7 equals 5. And look at the solving now. X is just negative 2. I didn't even get that extra answer, which was that extraneous solution. So you look at the two methods, both of them worked. You just have to be careful now. You got to look out for which method would be the most efficient, which method would be the best one to use in this scenario, okay? So that's number 4. Now, numbers 5 and 6, we got two fractions going on, but the way in which we solve it does not change. There is one additional first step option you can do though, okay? One thing you can do is you could add those two together first if you want to, okay? That is more than okay. I'm not going to show that in this method in the solving method, in the solving problem, but that is one thing you can do. Just like here, your first step you take is you could subtract those and make it one fraction. Okay, that's okay to do. Use the properties we learned previously in this unit, and you could make it now fraction equals fraction, right? Instead of two of them on one side, but you don't have to. I'm going to show the method where we make common denominators and then get rid of it. So I've got a 3, a 2, and a 6. I'm going to make common denominators of 6. This one needs a 3. This one needs a 2. So we have 2x over 6 plus 3x minus 9 over 6 is equal to x plus 1 over 6. If we multiply both sides of the equation, since everything is being divided by 6, multiply both sides of the equation by 6, we can cancel out all of our denominators, and now we have a pretty simple equation right here to solve. How do we solve it? It's linear. Move the x's, move the numbers, get x all by itself. So what we have here is 5x minus 9 equals x plus 1. Take it a step further, move x to this side, move the 9 to that side. Oh, that's a 10, sorry about that. And we get 10 fourths, which is 5 halves. And that would be your solution. If you plugged in a 5 halves in for each of these x's, it would be one side equals the other. We solved it, we're good to go. And then number 6, once again, feel free to make this one fraction if you'd like to. I prefer, my personal preference is to make common denominators first and then go from there. This one is subtraction though, so we are going to have to be very careful with this negative sign into this second fraction. We're going to carry that negative in when we distribute. So we got to look out for that, okay? Get rid of these arrows here. All right, so I need to determine common denominators, I need to factor. So I need to just rewrite this as x minus 5, x plus 2. Well, notice that these are part of it. It has like one of the factors, it's missing the other. So if it's ever missing a factor, you literally just put it next to it, right? Whatever it doesn't have is what you multiply by. So this one needs an x minus 5. This one needs an x minus 5. This one needs an x plus 2. Remember, you do it to the top and bottom to keep it balanced, and now we're set. So we have the same common denominator on all of these. Now, what we have to look out for, though, is the fractions that we have that are going to get multiplied to cancel. It is a little bit messy right now. Sometimes it is beneficial to rewrite the whole thing just for space purposes. I mean, so I'm just going to do that to show the work and hopefully see how it gets cleaned up pretty quickly. And we'll see that in just a second. I'm not going to distribute this one right now. I'm going to leave it just as is for a second. And then we'll see how it can be solved efficiently and hopefully pretty clean, and you guys can see the steps, okay? They all have the same denominator. Since they all have the same denominator, multiply by it to cancel it on both sides of the equation, and it goes away, okay? Please don't skip this step. It's really important to know that this is actually what's happening. And because since we're dividing by it, we can multiply by it. And when you do that, it cancels your denominators here. We can multiply by it, undo division, and it cancels your denominators here. So look what's left over. See the tops here? We need to distribute in this 2, and we need to distribute in this -3 into both of these. So I'm just going to show that in one step. 2x plus 4 minus 3x plus 15. Notice I carried the negative, equals 4. Continue solving. Negative x plus 19 equals 4. Finish solving, move the 19. Negative x is equal to negative 15, and we know x is then positive 15. If we were to plug it in, we would see we have the correct answer, nothing we'd need to check or nothing we would need to fix at that point, okay? So that is the second video from page 2 of the classwork documents. Hopefully you guys were taking notes through this. You, at this point, can start working on the homework assignment and look back at this video anytime you'd like for, the ways in which we solve either cross multiplication, great technique, careful with extraneous solutions. Those will start showing up as we go. Otherwise, create a common denominator, get rid of it, and then you can continue the solving process. That is it for today.